All right, my name is Megan Ganaway. We are going to talk about the estimating problem. So, in the case study presented by Kersner in 2017, a project manager is assigned to a project after the estimating team compiles an estimate of the time it will take to complete the work along a critical path. When the project manager reviews the estimate, experience tells her that the schedule will be unattainable as the timeline for certain work packages seems unreasonable. The project manager then confirms this with the available subject matter expert and is then concerned that the project's success will be in jeopardy. There is a difference of several weeks between the estimating team's timeline and what the project manager thinks is reasonable. This difference will make delivering on schedule difficult, as it does not seem there's much float time elsewhere in the project. As a project manager, success and failure is defined within the statement of work, meaning if a measure of success within the statement of work is an on-time delivery, keeping a realistic schedule and ensuring all stakeholders have a reasonable expectation of timing is crucial. Without a realistic estimate of time, the schedule will be skewed and perhaps even unattainable. While an earlier estimated delivery might please stakeholders, it means finishing on time is less likely, and therefore there's more risk in maintaining the schedule. Additionally, an unrealistic schedule could mean a more costly project. If an estimate is too short, paying overtime could mean more dollars in labor costs. On the other hand, if an estimate is too generous, it could mean a longer timeline overall, in which case project selection might be affected. Again, looking back at the statement of work to see if completing the project on budget is part of the success metric will be important. Typically, finishing projects within budget is a measurement of project success, and the measure is not simply the total that was spent on the project, rather it is the amount authorized compared to the amount spent. If the estimates are low for labor, then the risk of overtime or the need for additional labor will jeopardize project completion within budget. And finally, the project scope is the definition of what will be included and what will be excluded from the project. If the project does not deliver what is listed in the project scope, the project success is in jeopardy. If an estimate includes assumptions that are not part of the scope, again, success is in jeopardy. The problem with estimates in this case study is that they are unattainable, and this puts the project and therefore the project manager at risk for failure. So what then is a critical path, and why is it important? Knowing a project's critical path is helpful as completing the work in this sequence ensures a project will stay on time. If work along this single path takes longer than estimated, the entire project timeline is at risk. Thus, project managers should ensure the estimates for this work within this path are well vetted, in addition to keeping them at the forefront of thought throughout the project lifecycle. Indeed, one study even found that the critical path management was able to decrease hospital stays, thereby decreasing cost and contributing to better patient outcomes. Indeed, the critical path is just that, critical to staying within the schedule. The critical path is displayed graphically along a timeline with other sequences of work weaving in and out as necessary. This type of depiction helps to highlight which events are critical to the start and end times of the schedule and where there could be float time to make up for unexpected constraints. An example of a critical path in the slide we see here. In the case study by Kersner again, the project manager is faced with the critical path timeline being underestimated. The project manager was not involved in the estimating process, so meeting the timeline for critical path seems impossible, even after investigation. The project manager will have to decide if there is a way to change the estimates or otherwise redirect resources to ensure the critical path is completed on time. Because that seems unlikely, the project will perhaps finish within scope, but outside of the timeline, and therefore could incur a financial penalty. That penalty, coupled with the additional resources necessary to complete the project, could result in the project being over budget and therefore not successful. However, because the project manager is reviewing the estimates prior to the start of the project, perhaps a change could be made. The estimating team, after all, did not use a complexity factor, which seems to be throwing off the timeframes. For example, it is impossible for the project depicted on the slide to finish sooner than the time it takes to complete the work from A to D. If the estimate to complete the work from E to F is 2 weeks, but the work is completed in 1 week, the project still cannot finish 1 week earlier. Instead, the time it takes to complete the project is dependent upon finishing the work from A to D, regardless of how long it takes to complete the other paths of work. In the case study, the most important estimate is along the critical path, and getting the estimate estimate right makes the difference between finishing on schedule or not schedule. So what sort of options do we have when estimating work activity time? Expert judgment, analogous estimating, parametric estimating, three-point estimating, and bottom-up estimating are a few. Each have different pros and cons, and each are utilized in different ways. In the case study presented by Kerzner, the estimating team utilized a three-point estimating system. However, the assumptions utilized do not appear to be appropriately based on the expert's analysis. In this case, more emphasis could have been placed on expert judgment rather than utilizing a database with historical assumptions. On the other hand, a firm with estimating team likely depends more on algorithms and therefore should have utilized a triangular distribution formula. The use of this formula clarifies the expected duration by eliminating some uncertainty. The final estimate in the case study presented by Kerzner was a total of 12 weeks. The optimistic was 4, the pessimistic was 16, and the most likely was 13 weeks. There are 3 data points used to arrive at the conclusion that the work along the critical path would take 12 weeks. Estimating in this way, using the most likely time to complete based on the functional manager's input, the assumption that all will go well, and the assumption that maximum difficulties will occur is a standard way to estimate activity time within projects. However, in this case, the project is more complex than normal and the project manager has experience with similar work packages. Because of this, it is important to revisit the estimates and think critically about what biases might be involved, what calculations were or were not utilized, and if a revision to the schedule is warranted. However, if the schedule has been approved by the customer, it could be prohibitive to change the timeline at this point. Again, emphasizing how important it is to get the estimate time correct, especially along that critical path, which is most important to the schedule. Finally, successful projects generally need to be completed on time, on budget, within scope, and add value to the organization. Ensuring that critical path estimates are as accurate as possible will contribute to finishing the project on time. The goal of project management in general is to have more project success driving work forward, and therefore greater organizational success. Part of achieving these goals is to complete projects within the measures of success, typically scope, schedule, and budget, and ideally through an approach that keeps employees engaged and morale high. In the case study, it is evident that the activity time estimates and the project manager disagree. This jeopardizes the success of the project, especially because being on time and on budget are generally measures of overall project success.